guys. So in this particular session, what we'll be looking at is finding out multiple, multiple, you could say, regression analysis from your assumed mean. Okay, so we will be using Kriti's publication statistical methods. So that is our question, and then the question is 27C. Okay, so what we've been given is that we've been given the means. Okay, so 16, 13, and 6 has been given. So what's our, see, all this x are in small x, that means it's x minus x bar, right? So it's a subtracted value from the mean, right? So what, it's the deviation basically, you know. And then after that, after that, you have your x1 dot x2 is given, x1 dot x3 is given, the small x. Okay, so after that, what we've been also given is that x1 square is given, x2 square is given, x3 square is given. Okay, so what we need to solve for is a yx1 on x2 and x3. What is the equation? It has just asked us equation only. Okay, so we know x1 is equals to, we don't need the intersect over here. Okay, v1 x2 plus v2 x3. Okay, this is our first equation. So we multiply it with summation, right? Summation x1 is equals to v2 summation x2 plus v1 and v2 summation x3, right? This is our second equation, and then again we multiply it with x2, right? x1 dot x2 is equals to b1 summation x2 whole square plus again b2 summation x2 dot x3. Okay, this would be our third equation, and then fourth equation would be multiplying with x3, right? b1 summation x2 x3 plus b2 summation x3 whole square. Okay, this would be your fourth equation now, or you could say substituting values in various sum. So how much will we get? So what's our x1? No, I mean like in this and this. So we just replace the values in third and fourth. Okay, so x1 dot x2 is 21, right? And then x2 whole square is x2 square is 10b1 plus what's our b2? b2 x2 dot x3, right? Summation x2 dot x3 is 10b2. How could that be? Okay, these and these are same, that's why. So this will be our fifth equation. Sixth equation would be x1 dot x3 28 as equals to b1 x2 dot x3 would be 10b, right? 10b1 plus x3 square is 14, right? So when you look at this equation, as you can see, if you subtract 5 from 6, the 10 and 10 would go. You will only have your b2 and you'll get your b2. Okay, now what we'll do is that we'll just subtract this. So when we subtract it, or when we subtract this from this, what will happen is that, so it would be like this. Okay, we'll just change it. 28 and 21, right? So subtracting 5 from 6, right? 10 and 10 will be cancelled out, and then basically this will be minus, this will be minus as well, right? So 4b2 is equals to 7, right? Therefore b2 is equals to 7 by 4. This would be 1.75. I guess let's not make the mistake of being confident. 1.75, right? So what we'll do is that we'll just put these values in any equation, any b1, b2, whichever you would like, okay? So I'll just put it in 5, okay? So what I'll do is I'll just rub this thing. So I can just do it on the top. So it will be 21 is equals to 10 times b1 plus 10 times b2, right? So we are replacing the values for b2, right? Substituting b2. So 10 b1 plus 10 into 1.75, right? 21. Or 10 b1 is equals to 21 minus, how much would this be? 1.75. So 1.75 into 10, I think it would be 17.5. Yep, 17.5. Therefore b1 is equals to 21 minus 21 would be 21 minus 17.5 would be 3.5, and then divide by 10 would give us, 0.35. Yep, 0.35. Okay, so now we have achieved b2 and b1 as well. So all we need to do is that put those values in this, and that's our equation. Okay, so if we put those values in, putting the values of b1 and b2 in equation 1, we get x1 is equals to, and what's the b1? 0.35 x2 plus 1.75 x3. Okay, so this is our equation. So if the question says anything about x2 and x3, what would be the dependent variable? So you just put in the values, multiply it, you will get your dependent variables figure. Okay, so another thing that we need to be careful about is once we get our equation, okay, from the mean and everything, once we compute it, so what we will need to do is that, since we've already computed b1 and b2, right? So what we need to do is that, so since this is a small x, right, so we need to open it up. Okay, so what we will do is that, or x1 is x minus x bar. Okay, x1 bar. Okay, so again this thing as well, 0.35 x2 minus x2 bar. Okay, same thing for x3 as well, 1.75 x3 minus x3 bar. Don't miss this step. Okay, so because at the end of the day you might only be given x1, x2 and x3, and then you might have to predict it. Okay, so since the small x is only the deviation or the subtraction from the mean, right? Or x1 minus, what's our x1 is 60, right? So can just erase this thing. 16 is equals to 0.35x2 minus 0.35 into x2 is how much? 13, right? Plus 1.75x3 minus how much is our x3? 6, right? 1.75 into 6. Okay, therefore x1 is equals to 0.35x2 plus 1.75x3, and then how much would that be? 16 would go over there. The other values would be basically 16 minus 0.35 into 13 minus 1.75 into 6, right? This is 1.75. So this will be 19 by 20, so that means plus 0.95. Okay. So all we need to do is that open it up, and then we will get our x1. Okay, x1 on x2 and x3. So if we've been given x2 and x3 in the question, we can compute it using this question. Okay. So yeah, if you've been asked from assume mean method, we use this particular method. Okay, it's pretty easy because it does not take time as the matrix one, like, right? And then it's just basically all we need to be careful about is when we are basically subtracting 5 from 6, the equation, sometimes we might have to multiply it as well. Okay, remember that will be very crucial step. In this case, it's already 10 and 10. So suppose if this would have been 20, what would I have to do? We would have to multiply this equation by 2 and then only subtract it. Okay, so just need to be careful in that. Otherwise, it's pretty same and similar. Okay. So next on, we will look at how equation is computed from standard deviation or simple correlation. We'll look at that as well. So if you have any confusions regarding this kind of question, please do comment down below. I'll be happy to answer it for you. Until next time, bye bye.